If we take the expressions that we derived for the Euler integration method, remember that this was the algorithm, we notice that this is actually a difference equation. In contrast to differential equations, which involve quantities that depend on a real label, time, here we have a relation between quantities that depend on integer labels. So m labeled at m plus 1 is equal to m labeled by n. We're going to try to solve this difference equation exactly. So the solution will be written down here. We start at t0. The initial condition tells us that the value of m at time t0 is m0. And then we apply the rule that was given by the Euler algorithm. At t1, to obtain m1, we multiply m0 by this factor. We're going to do the same for t2. m2 is equal to m1 multiplied by the same factor. But now let's assume that we want to express m2 as a function of m0. For that, we will use the expression that we derived for m1, and we get m0 times the factor squared. Doing the same thing for t3, we get m3 equal m2 times this factor, but we would like to have it in terms not of m2, but rather of m0. We go back to the previous line, and we see that the expression for m3 is m0 times the factor cubed. We proceed to the last step of the integration, Tn, and m sub n is equal to m0 times the factor to the nth power. Here we're going to use the definition of the integration step, which was the length of the integration interval over the number of steps that we take in the Euler integration scheme, and we can rewrite this expression in this form. This form should be familiar to you. This is basically the expression for discrete compounding with an interest rate that is equal to that. N was the number of steps. What we're going to do is take that n going to infinity. Of course, delta t is going to go to 0. It's going to remain positive, but it's going to go to 0. And we're going to take carefully this limit in such a way that capital T goes to a constant. If we do that, this is basically the expression for the exponential, which incidentally is also one of the contributions of the Swiss mathematician Leonhard Euler.